Every so often, a single research paper comes along that just completely changes the game. And in 2020, one landed that did exactly that for artificial intelligence. What's wild is that it wasn't about some fancy new algorithm. Nope. It was about a simple, almost brute force idea that unlocked abilities in AI that nobody really thought were possible yet. So let's dive into this thing because it's the story of how we got to the AI world we live in today. All right, have a look at this paragraph on your screen. It's a pretty standard news summary, right? It's coherent, it gives you context, it even quotes a source. It feels exactly like something you'd skim on a major news site.
But what if I told you a journalist didn't write that? What if it was created by something else? The big question is, could you even tell the difference?
Yeah, you guessed it. That was written by an AI. And here's the kicker. It was an AI that had never, ever been specifically trained to write news articles. This unbelievable trick was just one of the bombshells from a 2020 paper called Language Models Are Few-Shot Learners. And it was our first real introduction to an AI model named GPT-3.
So to really get why this was such a massive deal, we've got to unpack the story told in this paper. We're going to look at how AI used to be done, then this simple but totally radical idea that flipped everything on its head. We'll see how they built this absolute beast of a model, look at the jaw-dropping results, and finally talk about its legacy and the really important warnings the creators gave us right from the start.
So let's rewind the clock to before 2020. Back then, if you wanted to teach an AI a new skill, say summarizing articles or translating languages, it was a long, painful process. We were living in the era of what's called fine-tuning.
So what exactly is fine-tuning? Well, think of it like this. You have a world-class chef who's mastered all kinds of cooking. But if you want them to learn how to make one specific new sandwich, you have to send them back to culinary school for weeks with thousands of examples of just that one sandwich. That's what we were doing with AI.
You can just imagine how unbelievably inefficient this was. For every single new skill, you had to go out and collect a massive custom-made data set with thousands of labeled examples, and then retrain the model on that specific data. Wanted to translate German now? Awesome! Go find 10,000 German to English examples and start the whole expensive process all over again. It was slow, it was costly, and it really held back how useful AI could be.
But the GPT-3 paper asked a different question. The researchers wondered, what if an AI could learn more like us? What if it didn't need thousands of examples, but could learn a new task from just a handful, or maybe even just from a simple instruction? This was the beginning of an idea they called few-shot learning.
Okay, so instead of sending our master chef back to school, what if we could just show them a picture of the new sandwich and say, hey, can you make this? That's the beautiful simplicity of in-context learning. No retraining, no massive new data sets. You just give the model a few examples, a few shots, right in the prompt you give it, and it just figures out the pattern on the fly. It's fast, it's flexible, and it means one AI can suddenly do a ton of different things.
But how on earth could a model just do that? Well, this is where the researchers made their huge, monumental bet. They had a hypothesis. Maybe the secret wasn't some fancier, more complicated algorithm. Maybe the secret was just making the model so mind-bogglingly massive that these incredible new abilities would just emerge on their own. The key, they bet, wasn't complexity, it was scale.
And believe me, when they said scale, they were not kidding around. To actually test this wild idea, they had to build the single largest language model the world had ever seen. It was a truly monumental undertaking.
The final result, GPT-3, came in with 175 billion parameters. So what's a parameter? The easiest way to think about it is like a tiny, tunable knob inside the AI's brain. Each knob helps it figure out the relationships between words and ideas. So having 175 billion of them gave it this insane capacity to absorb the patterns of pretty much all of human language.
This chart really puts it into perspective. The model before it, GPT-2, had about 1.5 billion parameters. The biggest one on the block at the time, from Microsoft, had 17 billion. GPT-3, with 175 billion, wasn't just another step on the ladder. It was a 10 times leap over the closest competitor. This wasn't just progress, it was a total change in the scale of our ambition.
And to train this monster, they basically had to feed it a huge portion of the readable internet. We're talking 45 terabytes of text taken from a snapshot of the web called Common Crawl, plus massive collections of books and the entirety of English Wikipedia. This model essentially read more text than any single human could get through in 1,000 lifetimes.
So,
The team built the biggest model in history and fed it a library's worth of text. The big question remained, did their massive bet on scale actually pay off? Well, what happened next was even more surprising than they could have possibly hoped for.
All of a sudden, GPT-3 could do things it was never, ever taught to do. It could perform 3-digit addition and subtraction. It could unscramble words. You could literally invent a new word, define it, and the AI could start using it correctly in a sentence. It could fix grammar. It could write basic computer code. And yeah, as we saw, it could generate convincing news articles. These weren't program skills. They just emerged from the sheer scale of the model.
Now check this out. This is one of the most stunning results in the entire paper. There was this trivia challenge where the best AI in the world was a specialized, fine-tuned model that was allowed to search the web for answers. It was an open book test, and it scored 68%. Then came GPT-3. With just a few examples and, get this, no access to the internet, a closed book test, it scored over 71%. It beat a specialized model that could cheat by just using the knowledge it already had stored in its parameters. Incredible. And remember that news article from the start? When they actually ran a formal study, they found that people could only tell the difference between a real article and a GPT-3 article about 52% of the time. That is basically a coin flip. The AI's ability to mimic human writing wasn't just good, it was uncanny.
The release of this paper wasn't just another step forward. It was a true inflection point. It didn't just give us a new, powerful model. It kicked off an entirely new chapter in AI, and we are all living in the world that it created.
Before this paper, the whole field was mostly focused on building specialized little models for every individual task. But after GPT-3 proved just how powerful scale could be, the entire industry pivoted. The great LLM race began, the race to build bigger and more general large language models. And pretty much every generative AI tool you use today, from ChatGPT to coding assistants, can trace its roots right back to this paradigm shift.
But to their immense credit, the authors of the paper were incredibly clear-eyed. They knew they'd uncorked something really powerful, and with that power came new problems and some very serious responsibilities. A huge chunk of their paper was actually dedicated to the model's flaws and the ethical dangers it introduced.
They were very upfront that scale, while amazing, didn't solve everything. GPT-3 could still get confused and lose track in really long conversations. It didn't have any real-world common sense, and it could confidently just make stuff up, what we now all call hallucinating. It was a brilliant parrot, but it wasn't a true thinker. And of course, the energy cost to train a model this huge was just astronomical.
And even more importantly, they flagged the huge societal risks. A tool that can generate endless amounts of convincing text could obviously be used for misinformation, for spam, for phishing, all at an industrial scale. And because it was trained on the internet, it learned all of our biases. It learned to reflect harmful stereotypes about gender, race, and religion. These are the exact, critical conversations about AI ethics we're still having today.
In the end, the GPT-3 paper was proof that just making something bigger could unlock intelligence in ways no one had fully anticipated. It completely set the agenda for the world of AI we find ourselves in right now. But it also left us with this huge, lingering question. If pure scale got us this far, what are the next breakthroughs? The things like true reasoning, genuine common sense, and safety that scale alone just can't solve. That is the next great frontier.